So before we start the experiment, it is very important to talk about the objective, because knowing our objective is key to getting the results we want. Setting a clear goal helps us understand what we want to achieve and give us a plan for how to do the project. So this clarity not only help us figure out how to do things, but also help us figure out how well our experiment worked. By setting a clear objective, we can make sure that our work is focused and that the results are useful. Throughout the laboratory session, students are expected, number 1, to separate and identify at least 2 colored components from a chosen soluble marker ink using paper chromatography within 45 minutes. 2. To determine if a chosen soluble marker ink consists of a single colored component or a mixture using paper chromatography. 3. Calculate the retention factor for each separated components in the chosen soluble marker ink using paper chromatography data. 4. Test 2 different solvent systems for separating the component of the chosen soluble marker ink and identify the system that yields the best resolution within 2 trials. 5. Develop and validate a paper chromatography procedure for separating components and soluble marker inks with at least 80% success rate among students performing the experiment for the first time. So after the objective, we will now begin with the experiment.
Good day everyone, so we are group 11 and I'm Johanna Ray Alvarez.
And I'm Mark Lawrence Asasado. So today, we are doing experiment 15.
Which is paper chromatography. Our goal is to create a paper chromatography using marker and ethyl alcohol. Our materials: beaker, watch glass,
Katabi at kapiling ka Ikaw hindi mag-iiba Pagtingin ko sa'yo ay hindi maipita Kahit nasabi nila bumamahal ko sa'yo ay bababag daw at ikaw daw ay iiba sa kanila Sabi ko naman
Paper chroma,
and ruler,
pencil,
scissor.
and most importantly, marker.
First, we're gonna pour an amount of 50 ml ethyl alcohol.
Into the beaker.
Yes.
Then we're gonna cut the paper about 1 inch to form a point at the end. Then we can draw a line to determine the end point.
And now, we'll use day marker to make a good size dot of color about 1.5 centimeter up from the pointed end of the paper. We're gonna hang the top of the paper to hold the strip at just the right level of the paper.
Then we're gonna place a tape to secure
The paper.
filter paper when we dip it in the ethyl alcohol.
Here we just have to wait for the solution to completely cover and spread the ink to see beautiful different colors. After we dip the first ink, here are the results of its color. Additionally, we have already tested the second ink, which differ from the first one in both size and color it produces. By examining this difference, we can better understand the unique properties of each ink and how they perform under condition. So now we need to identify the different colors and their measurement travel from the first experiment to the last. So after we determine the the color and the measurement traveled from the first to the last experiment, we now have to calculate for the retention factor. So here we have an example computation. In the left table, we have the RF value of distilled water, and from the right table, we can see the RF value of ethyl alcohol. In conclusion, paper chromatography effectively separates a mixture like ink into its different components. We can distinguish these parts by their color and distance they travel on the paper. This method provides a clear visual representation of the different substances within a mixture. I hope you have a better understanding of paper chromatography after seeing this video. And as always, without our amazing Miss Tabuklin, who sacrificed her all for us every day, none of this wouldn't be possible. We are grateful, Miss Tabuklin. And I would like to end this video and my last experiment with Joanna Alvarez, my lab partner. Now, over the past 5 months, working with you has been enjoyable and enlightening. We now reach the end of this chapter. Thank you.